Hi, my name's Mark. I'm here to help you with your Maths, GCSE and A-level studies. This week's topic, well, we are doing something a bit different. We're not specifically looking at a particular topic, but we're revising a couple of topics that we've seen before. We're going to be focusing on the GCSE content. We'll do some higher and some foundation questions. This topic will be based around the number section in the GCSE course. We will look at how you deal with fractions and how you work out recurring decimals. Recurring decimals being the higher part of the GCSE course. This is revising topics we've done this term previously. The tip for the fractions topic is you need to remember if you're adding, taking away, timesing or dividing. And there's a different routine for both. The tip for the recurring decimals topic will be you either multiply it by 10, 100 or 1000. That depends on the length of the recurring part. We will see that in the exam question later. So we're going to deal with 2 exam questions in this video. As always, don't be afraid to make mistakes. That's the big part of the learning process. But let's have a look at this first question. This first question is 2 1/3 times 3 3/4. If it's a show that question, just remember you can't write down the full answer like it's displayed. What you need to think of is, imagine they don't give you the answer as 8 3/4. You have to find that as your final answer. Show that questions are usually a bit nicer because you know if you've got the answer correct or wrong. So 2 1/3 times 3 3/4. First things first, we will look at this and think, oh, they are both in mixed number form. So what I would always suggest you do when they're in mixed number form is convert it to an improper fraction. We do this by timesing the 2 by the 3 and then adding the 1. Because 2 is the same as 6/3, and then add the 1/3, it would become 7/3. You're not writing anything different, you are just writing an equivalent fraction, but instead of mixed number form, it is in improper fraction form. You do the same with the 3 3/4, you times the 3 by the 4, and then add the 3. So that's 12, add 3 is 15, it will be 15/4. What we see that now is it's 2 improper fractions, and then put the sign down. I always put the sign down last because it reminds students that what are we doing with these 2 fractions? We are only multiplying them together. Now remember, when it's add and subtract, you need the same denominator. But when you're multiplying them together, what you can just do is multiply the numerators and multiply the denominators. If it's dividing fractions, you have to use K, C, F. Keep, change, flip. So timesing is the easiest one of the 3. You have to times the numerators, 7 times 15, and times the denominators, 3 times 4. These usually come up on non-calculator papers, so what I would just do is do a bit of 7 times 15, a bit of long multiplication, or you can try and attempt it in your head. But 7 times 5 is 35, carry the 3, 7 times 1 is 7, add the 3, remainder carried over, and you get 105. So the numerator, the 7 times 15, is 105. The denominator, 3 times 4, is 12. First things first, what I would suggest you do is see if you can simplify. See if anything goes into the numerator and denominator. And a quick way of doing that is, instead of writing 12, if you split it up into its prime factors, so you could do 2 times 2 times 3. Same thing for 105, you notice 5 goes into it, 5 times 21, because 25 is 100, another 15 is 105, and you can split the 21 into 3 times 7. Oh, it has a common factor on the numerator and denominator. You can remove the 3's, so you can divide top and bottom by 3. And what that does is leave you with 35 on top, 5 times 7, and 4 on the denominator. Then, if you have simplified it now, because the only prime that is in the denominator is 2, and there's not a factor of 2 in the numerator. Then it doesn't specify to simplify or write it in mixed number form, this exam question, but it does say show that it's 8 3/4. So, going back to 35 over 4, you do 35 divided by 4, because remember the fraction sign is a divide symbol. 35 divided by 4, that's not the same as 4 divided by 35. So remember to get your order right when you're doing division. And you would get 8 fours of 32, remainder 3. So that's why you would have 8 as your full number, your whole number, and 3/4 remaining. We are dealing with quarters here because it's 35 over 4, 35/4. So we have shown it becomes 8 3/4. So that's the first exam question we'll do today, and that's your foundation bit of revision for this term. Right, so next we're going to move on to the higher paper revision. Let's have a look at this question we're dealing with. So this question is on recurring decimals. And as specified, this is for higher paper students, usually aimed at sort of the targeting grades, so about level 3. Sorry, not level 3. The question we've just done is aimed at level 3 students. The higher paper question, the recurring decimal topic, is aimed at level 6s, level 7s. Okay. So what we're going to do is have a look at this particular question. You need to prove that 0.136 with the 3 and the 6 recurring, notice the length of the recurring part, times 0.2 recurring is equal to the value 1 over 33. So it does involve a bit of fractions in the number section, but takes the topic to a slightly new level. Right, so what I would suggest you do is calculate each fraction individually. So what I mean by that is, okay, you let x equals 0.136, and notice the dots are above the 3 and the 6. So what that means is it's only the 36, the 36, the 36, the 36 is recurring, not the number 1. The dots are always put above the start of the recurring part and the end of the recurring part. They don't have to be put in between, but everything between the two dots is recurring. Now, some schools teach to do, say, 1000x and 10x, but what I like to say is just check out the length of the recurring part. Here, the length of the recurring part is 2. So length of recurring part, so you've got 2 digits that are repeating. The 1 is not, okay, but the 3 and the 6 are. Length of recurring part is 2. So if that's the case, you need to move the decimal point 2 times. And to do that, you will deal with 100x. And I like to write that above the x. So you've got 100x equals. And if you move the decimal point twice, you would have the 13, 1 and the 3. And then you would have the 6 after it. And then after the 6, it will be 3, 6, 3, 6, 3, 6. You move it twice, so if you'd only moved it once, you would have 6 above the 3's and 3's above the 6's, and they won't line up. But now, because you've moved it twice, 3 6's above each other again. And you do that so that you can subtract them away from each other, and it will create a terminating decimal. All these would become zeros because it's lined up. And just be careful, not everything after the decimal point becomes 0, but it will be a terminating decimal. 6 take away 1 is 5, 13 take away 0 is 13. Just remember to do the left hand side as well. 100x take away x is 99x. So what you have here is 99x equals 13.5, and that's as an exact number. Then what you need to do is remember to divide through by your 99. So x equals 13.5 over 99. This is strictly not a fraction yet because it's still got a decimal, and this is where the technique about using 1000x and 10x differs from using just 100x to start off with and then manipulate your decimal into a fraction at the end. What you could do is times the 13.5 by 10 and times the 99 by 10. That's absolutely fine, but then you'd have to simplify larger numbers. So if you know 0.5 gets doubled to become an integer, you could just times the numerator by 2 and times the denominator by 2. 13.5 times 2 is 27. 99 times 2, 100 times 2 is 200, that's the 2. So 198. Again, what I would do is always look to simplify. 27 is just 3 times 3 times 3. So the only way it could simplify is if there's a 3 in the denominator. And now I believe there is, because if you do 3 times, well, 99 is 3 times 3 times 11. 3 times 3 times 11. And then you're timesing by 2. So actually 2 of the 3's cancel because there's a 9 in the numerator and the denominator. So what we're left with here is it cancels down into 3 over 22. But that is just the 0.136 recurring, 3 over 22. We need to do a similar job for the 0.2 recurring. That's usually a bit easier, but let's begin it now. You can use a different letter or x again. I'm going to use y. X equals 0.2222. If you notice now, okay, the length of the recurring part, now you've only got one digit that's repeating. So you only need to move the decimal point once. So I'm going to use 10y equals, move the decimal point once, you've got 2, keeping the decimal point still above the decimal point, but you've got 2.2222, etc. And then you draw a line underneath them and subtract one away from the other. 10y take away y is 9y. You have a terminating decimal because all the digits after the decimal point here cancel. And you're just left with the number 2. And you get y equals 2 over 9. And you don't have to manipulate that because they are both integers, 2 and 9. Just as a little tip, if ever you see a number recurring, say number 0.2 recurring or 0.3 recurring, it's that number over 9. If it's just a singular number that's recurring immediately after the decimal point. Right. So let's go back to the question at hand and finish this particular question. So the 0.2 recurring is 2/9. I think in maths where you just replace a value with an equivalent value because sometimes it makes the calculation simpler. You've got 3 over 22 times 2/9. So you're timesing them both together. Right, so again, when you're multiplying fractions together, you just times the numerators and times the denominators. Again, you can multiply out and then simplify, or if you want to keep it in prime factor form, 3 times 2. You split the 22 up into 11. You can only do this when it's multiplying, but 11 times 2 times 3 times 3. And you notice a 3 cancels. If you divide top and bottom by 3, you can simplify it to become 2 over 11 times 2 is 22, times by 3, and then it becomes 66. Oh, my mistake. If you notice, there was a 2 on the top and the bottom as well, so you can divide top and bottom by 2. Divide top by 2, divide the bottom by 2, you're left with 1 over 33. There's nothing wrong, as I've just proved, in making a mistake. It's how you realise you've made a mistake and how you deal with that situation. Nothing I wrote there was incorrect, but it just didn't simplify fully. So I've simplified fully in my final answer. 2 over 66 is the same as 1 over 33. And that's what we were asked to prove. Prove is another way of saying show that. And you have to show that the result is 1 over 33, which we have done. Right, so that brings us to the end of a bit of recurring decimals revision. I hope you found that video useful. Always be aware that I have my own extra videos on the members area of my website, as well as my live office hours streams. If you want to ever join to ask me any questions, it doesn't have to be on this week's topic. It can be on questions from school, homework, revision towards your exams. I'm here to help. Remember, working hard and being prepared to make mistakes and see where you've gone wrong and then correct them for future will be worthwhile when it comes to your exams. I'm happy to help you, whatever questions you may ask. I hope to see you in my office hours live streams this week.